Good evening, Gagana, Rachana, Sahiti, and Rudra.
Good evening, ma'am.
Good evening. How are you all?
Fine, ma'am. How are you, ma'am?
I'm good. Okay, everyone, turn on camera. Yes, Nayanika.
I said good evening.
Good evening, Nayanika. Good evening. How are you? Okay, so today we are going to. Okay, great. So today we are going to start next chapter of our syllabus, that is sound. Everyone, Gagana, Hansni, Rachna, and Rudra. Still, you are not visible. I think only Nayanika is visible to me. Okay, Rudra is here. Rest all of you, Gagana, Hansini, Prajna. Quickly turn on camera. Prajna, are you there? Okay, Prajna is also here. So quickly start the chapter. Next chapter, that is sound. Okay, so first of all, what is sound? So sound is in last chapter we studied about the different kind of energy. So sound is also a form of energy, and that energy travel through a medium. That medium could be air, could be water, solid, any medium which is made up of particles. So sound travels through the medium, and while during this traveling, it produces a sensation of hearing in our ears. So whenever object vibrate, so it sets a surrounding medium into vibration, and these vibration travel as a sound waves and reach our ears, and we are able to hear the things. Say for example, when we plug the guitar string, so they start vibrate and they are producing sound. Like I'm speaking this time. So in this time also, while I'm speaking, my vocal cords vibrate and they are producing sound. In your school also, there is a bell. Now we are having electric bells. So earlier times, electric bell also when bell rings. So in case the bell is of metal, so the metal surface vibrate and it creating sound waves. So whatever the reason, whatever the object, the reason of sound wave, sound propagation is the vibration only. So whenever there is a vibration, there is production of sound, or sound produced due to vibration of the object. So basically, sound is a form of energy that travels through the medium. Rajana, what you are doing? Rajana, what you are doing? Okay, and the main reason of the production of sound is the vibration of the object. So sound is produced due to vibration of object. So there are few examples of how the sound is produced due to the vibration of the object. Suppose we are having a rubber and we just hold it, maybe we just stick the rubber, just tie the rubber at the two ends, or maybe we can do one thing, we can take a rubber string, so we can hold one end of the rubber string in our hand and the other end in between the teeth. Okay, so I'm having a rubber string. So at one end of the rubber is in between my teeth and the other end is in my hand. So what is supposed to do? I just plug the any hand of the rubber or in between the rubber. So what happens? The rubber start to vibrating. And because of this vibration, simultaneously it will produce some sound and you can hear that sound. And after some time, when the vibration of the rubber string stops, then if there is no vibration, you are not able to hear any sound. Okay, so what we are doing, we are just tying a rubber string between two ends, and we just plug this rubber in somewhere in middle. So what happens by plucking this rubber in middle? This rubber start to vibrate. And once it start to vibrate, you are able to hear a sound. And after some time, automatically this vibration will stop. So once the vibration will stop, you are no more able to hear any sound. So this is very common example, very common experiment that you can prove that sound is produced due to the vibration of the object. Clear everyone? Clear everyone? So this is first experiment by which we can prove that sound is produced due to vibration of the object. So what we are doing, we are having a rubber, simple one string of the rubber band, and we are just tying this rubber band at two ends. Okay, like in this way, or there is one more method. You can keep one end of the rubber band in between your teeth and the other hand in your hand. So I am having a rubber band like this, like what? Like, are you getting what I'm saying? So suppose this is the rubber band. So one end in between my teeth, and the other hand is like this. Okay. And somewhere in the middle I'm plucking the rubber. So because this is not the rubber, so it is not going to vibrate. But if you are taking the rubber, so it will start vibrating. And once it start vibrating, you are able to hear a sound. And after some time, when vibration will stop, you are no more able to hear the sound. So that proves that sound is produced due to the vibration of the object. Okay, so there is one more experiment, that is this tuning fork experiment. So this is our experiment 2. With the help of tuning fork. What is this tuning fork? Can anyone explain to me?
A tuning fork is a type of like
Hmm.
device that is having different thicknesses as well as lengths, which
Hmm.
which create different sounds whenever you hit it on a surface, ma'am. And
Yes.
that air between the two bars of the tuning fork will vibrate, which causes
Hmm.
the sound to be formed.
Yes. So tuning fork, basically it is a metal made up of any metal like steel or aluminium. So what is this tuning fork first? It is made up of steel or aluminium. And these two arms, these are the arm of the tuning fork. And these are also called prongs or maybe stem or maybe handle. Okay. So in these are called prongs is a better way. So it is having two prongs. Prongs means the arm of the tuning fork. Okay, and these two arms are of one, so it is of equal length, and second, it is of U-shaped. Two prongs are of equal length, and these are U-shaped. So it's very much clear in the diagram also. These two prongs are of equal length and the shape in which they are, this is the U shape. Okay, now how they work? What is the how this tuning fork is working? So what we supposed to do, the two prongs, they begin to vibrate to back and forth. So when they are begin to vibrate, so once the tuning fork is struck on a rubber pad or any hard surface, so what we supposed to do, we just need to take a tuning fork and we just hit this tuning fork to any hard surface. So what happens when you hit this tuning fork with any hard surface? These two prongs start to vibrate back and forth. Okay, and these vibration, they set in the surrounding air into the these vibrations set the surrounding air into vibration, and these vibrating air produces sound waves. Okay, so there are so many experiments that we are going to discuss in this chapter with the help of this tuning fork. So this is tuning fork. Now, what we are doing here in this experiment, what we are doing. So what we are doing, we are taking a tuning fork and we hit this tuning fork with hard surface. So when we are hitting this tuning fork with any hard surface, so this tuning fork start to vibrate. Now there is a tennis ball. So this is a tennis ball. Okay. Now what we are doing, we are just suspended this tennis ball with the help of a thread near the tuning fork. Now you will notice that the arm of the vibrating tuning fork, when you brought it close to this ball, it jumps to and fro. It will start this to and fro movement because due to the vibrating tuning fork, this tuning fork will hit this ball and this ball will also start moving. And once the ball is start moving, you will able to hear the sound. And once the vibration will stop, there's no more movement in the ball and the sound will also disappear. So these are two basic experiments that will prove that sound is produced by the vibration. Clear everyone? Both the experiment?
Yes, ma'am.
Okay. Now, next important thing about the sound, that sound require medium to travel. So there is one more experiment and this is very common bell jar experiment. This is a very simple experiment. What we are doing, we are taking a bell jar and in this bell jar, we are putting the electric bell. Okay, and what is electric bell? Who will explain me electric bell? What is the function of electric bell and how it is a function? In earlier classes you would study now, maybe class 7th or 8th. How it function, electric bell. Yes, Rudra, tell me.
Mom, I did not understand the question.
Function of electric bell. Working of electric, not exactly function, the working of electric bell.
Ma'am, like when the bell rings, sound comes.
But how this sound comes?
Ma'am, like the
Hmm.
uh, ma'am, like a small type of hammer hits the steel wala thing and sound
Ah,
because of
yes.
the vibration of the steel thing, we get sound.
Hmm. Yes. Okay, so sound need a medium. So if there is no medium, sound wave will not travel. So there is simple experiment which is called bell jar experiment. So for this experiment, we need an electric bell, we need a glass jar with vacuum pump. Now what we are doing, so this is our a bell jar, a glass jar, and this is the electric bell inside the bell jar, and this is the vacuum pump. Okay, so what we are doing, electric bell will ring whenever the circuit is complete. So we will switch on the bell. Once we are switching on the bell, the circuit will complete and the bell is inside the jar. So bell will ring. So you will hear the bell sound. The ringing sound you will hear. Now next step, what we are doing? We are removing the air with the vacuum pump. Okay, and after removing the air, again we are after removing the air, again we are doing the same thing. We switch on the bell. So again circuit will complete, again bell will ring. But the sound, you are no more able to hear the sound, or maybe the sound becomes fainter or finally disappear. Why? What is the difference between these two conditions? In first condition, air is there. In second condition, with the help of vacuum pump, we are just creating a vacuum. Okay, so this experiment proved that sound require a medium to travel. If there is no medium, sound waves will not travel. So sound waves cannot travel in a vacuum. Sound wave need a medium, like it could be air, water, or anything, but it cannot travel in vacuum. So this is simple bell jar experiment that proved that sound wave require a medium to travel. So what are the main points of this experiment? So we just put the electric bell inside the jar. Bell sound is hot. And where is when air is pumped out. There is no more sound. When switch is on. So that prove that sound require medium to travel. Is it clear, everyone?
Yes, ma'am.
Everyone? Or it's clear for Nayanika only?
Yeah.
Clear, ma'am.
Clear? Okay.
Ma'am, could you show could you scroll up?
Sure.
Okay, ma'am. You can go back.
Done? Okay, so this is very common thing that everyone did in childhood. So what is this? What is this system? What what are these two kids are doing? Hmm. Yes. Yes, anyone?
Two cups are connected by a string, and when you talk
Uh,
through one cup, you can hear it to the
hmm.
different one.
Yes.
Because and the thread is the medium, you can say.
Yes, in this case, the thread is the medium and the sound waves are traveling through this thread. Okay, Rudra, show me your notes.
Ma'am, I wrote the first 2 points. I was having internet break, so I wrote the first 2 points.
Show me again. Only this much, two lines you wrote, only.
Ma'am, I was like, your video, like your screen was getting stuck for me, so I could not write too much.
Complete your notes first.
Yes, ma'am.
Internet, I don't think there is an internet issue from your side.
Don't know.
Complete your notes quickly. Hansini, show me your notes.
Ma'am, can you scroll up a little? I missed the first few points.
Ma'am, do we need to write down the experiments or
Yes,
if we
ma'am.
know them, is it enough? Because I know these
Yeah,
experiments.
Hansini, very good. What, Nayanika?
Ma'am, do we need to note down the experiments separately?
Experiment.
Yeah.
That you are talking about the diagram or the things about the just write in just 2-3 lines for your understanding only.
Because ma'am, I already studied this actually, so it's pretty general knowledge for me.
Because the whole experiment as it is though will not be there in the exam. There
Yes,
could be maybe 1 or 2 questions could be there based on this experiment.
yes, ma'am.
Ma'am, scroll down a bit, please.
Rachana? Rachana is there? Show me your notes. Rachana, are you there? Rachana, are you there? Charantej?
Yes, ma'am.
Show me your notes. Why you are late today?
Ma'am, scroll down a bit more to see the last part.
Ma'am, is my camera visible?
No.
Ma'am, is it like showing a camera symbol with like a slanted line?
Yes. There's
Yes,
a
like
icon with the slanting line. Yes. What
for,
happened?
for past few days, it's like coming like that only. I'm trying to like on, but it's not at all on.
Oh, which device you are using? Is it a laptop or what?
Laptop only, ma'am.
Okay. So maybe there is some issue with your camera. Just.
Ma'am,
Ma'am,
I think.
Oh.
ma'am, I'm showing my notes.
Okay, Nayanika. Good.
Sure.
Rudra, are you done?
Done, ma'am.
Okay. Good.
Ma'am, should I?
Okay. Yes, Governor, please. Okay. Very good. All the experiments are clear now, everyone? Okay.
Ratio.
Who is this?
Ma'am, Sahiti.
Sahiti, yes, please. Yes, Sahiti, very good. Okay, Sahiti, so experiments are clear now?
Yes, ma'am.
Okay, good. Okay, so as I told you, the sound require a medium to uh, travel. Okay, so see, sound is always produced by a vibrating body, and these vibration travel through a medium only. But what is this medium? What do you mean by medium? So medium could be any substance that contains some particles. Particles means the medium which is having some atoms or
Excuse me, ma'am.
molecules. Yes.
Ma'am, I had to leave the room for a second to open the door. They asked me to show my notes.
Yes, Prachna, 3 times.
Yes, ma'am, I had to leave the room for a second, ma'am. I wrote the notes.
Okay. Okay, Prachna. Good. Okay. So medium means what? Medium means any substance which is having some particles, which is having atoms or molecules. So what happens when particles vibrate? So due to the vibration of the particles, these particles transfer their energy from one particle to the next, to the means 1 to 2 to third to 4 to fifth. So in this way, they carrying the sound waves forward. Okay, so want to sound require medium, but what are the characteristics of the medium to produce sound? So next topic is characteristics of medium to produce sound. So first of all, medium means what? So medium is anything, any substance that is made up of particles. Particles means what? Particles means atom or molecule. Atom, molecules, everything you remember? Everyone? I forgot.
I remember.
Remember? What is atom and molecule? What is the difference, Charantesh, between atom and molecule?
Ma'am, atom is the tiniest particle on this world, like that it occupies matter.
Hmm.
Molecule are the groups of atoms.
Atoms of same kind or different kind?
Ma'am, different kind.
Atoms of different kind. For example, give me example of atom or molecule.
Ma'am, an atom can be like
Example only. Hmm. Yes, Gagana. Give me example of atom or molecule.
ma'am.
Yes.
Can I like tell it in the form of like the elements? For
Any form. Any form.
oxygen,
Oxygen is क्या? Is it atom or molecule?
atom.
Atom. Okay. Or molecule?
Carbon dioxide, like that.
Carbon dioxide.
Yes, ma'am.
अच्छा, okay.
Combination of two oxygen atoms.
Yeah, ma'am. O2, N2,
O2.
H2.
What is O2, N2, H2?
And
Di- Diatomic particles or diatomic gases.
Diatomic gases. Yes. And what is the example of atom? Give me one example of atom. Anyone?
Carbon.
Carbon.
C. Yes, C and these are atom. And what is molecule? Can we put what example you said, Charante? CO2.
yes, ma'am. CO2.
CO2. So can we put CO2 in the molecule category?
Yes, ma'am.
Yes, Gagana Nayanaka.
Carbon is for like atom and
Hmm.
group atoms like water and hydrogen make up molecule. For example, H2.
Okay, very good. Okay, so coming back to the sound. So, medium is anything which is having particles, and when these particles vibrate, they transfer their energy from one particle to another particle. Now, what are the characteristic feature? What are the requirements of a medium for producing sound? So, one first requirement is the medium must have particle. So, if there is particle, only then vibration could be produced and only then sound can travel. If there is no particle, then vibration cannot pass and sound cannot travel in that medium. Second characteristic of medium is the particle must be elastic. First characteristic तो यही हो गई. medium should have particles. Second characteristic is particle must be elastic. Now, what do you mean by elasticity of the particles? See, what happens, if the particles are elastic, so what happens, this elasticity allow particles to return to its original position after vibration. So, if the particles are returning to its original position, so that will help in continuous wave motion. Say, for example, air particles, water particles, they are the elastic particles. So, that's why they allow sound transmission. So, what happened due to the elasticity? This elasticity allows particles to return to their original position. So they are helping continuous wave motion. Say, for example, air, water, these particles are elastic. Now the third characteristic of medium. So third characteristic of medium is the medium must have inertia. Yes, Prajna, tell me, what is inertia? Prajna. Prajna, you are mute. I will choose you
Yes,
first.
ma'am. Ma'am, inertia is the resistance of a physical object to any state of motion. Like, no, in its state of motion.
For example,
Means the object will stay in rest unless an external force acts on it.
yes.
And an object, if it's in rest, it will stay in rest, and if it's in motion, it will continue to stay in motion.
Okay. And how many types of inertia we
And
studied?
there are 3 types of inertia.
For example,
Ma'am,
tell me the types.
Inertia of rest, inertia
Inertia of
of
motion.
inertia of rest,
Yes.
motion, and direction.
Very good. So inertia is it is the tendency of a body to resist any change in its state. State could be rest or could be in motion. So if a body is in motion, it always want to be in motion. And if a body is at rest, it always want to be at rest. So inertia means this is the laziness of a body. Okay, so body doesn't want to change what it is already doing. If it is resting, it always want to be in rest. And if it is in motion, it always want to be in motion. Okay, and on which law it based? I mean, which law of Newton it is
First
based?
law.
It is based on the Newton's first law. And what is Newton's first law, Rudra?
Ma'am, same inertia thing.
Yes, it is same. And Rudra, could you give me one example of inertia of rest?
Ma'am, like a person standing in a bus falls back when suddenly, like
Hmm.
falls flat when suddenly brakes are applied.
So in which direction it, suppose bus is, suppose buses start suddenly. So in which direction the passenger will fall?
Ma'am, if bus starts suddenly, the passenger will fall backwards, and the
Ha,
bus stops suddenly, the passenger will fall forward.
and the reason?
Ma'am, like inertia.
Inertia. So how inertia affecting this backward and forward fall? Hmm. Yes, Rudra.
Ma'am,
What
like
is the role of inertia in passengers falling in backward or forward direction?
I don't remember.
Yes, anyone else?
Ma'am,
Then, yes, Chanakya.
inertia of rest, like we can take an example of a tree which has leaves. So, like
Hmm.
if the tree is at rest, but like when we start to like push it, the
Hmm.
leaves fall down due to the inertia of rest. Like the downward path remain like at rest, but the upward path like is in motion. So that is
Hmm.
the cause for the falling of leaves. And inertia of motion, like when we are moving in a bus, like moving
Hmm.
bus,
Hmm.
if the driver applies sudden brakes, we tend to fall back because our lower body is at rest, but our upper body is
Hmm.
motion. So this is the cause for our backward motion. So these are the examples.
Yes. So inertia are of three types: inertia of rest, inertia of motion, and one is inertia of direction also. So inertia of rest is the tendency of a body to remain at rest until an external force act on it. So what happens when bus suddenly start, passenger fall backward because their body tend to remain at rest. So while the bus move forward, so they just fall backward. Okay. And inertia of motion is the opposite, the tendency of body in motion. So it will remain in motion with the same speed in same direction until you are applying some external force. Okay. Again, same example of bus. So when a moving bus stops suddenly, the passenger fall forward direction. Okay, so their body tend to continue moving. So they are moving forward direction. And direction, inertia of direction is the tendency of a body to continue moving in the same direction. Okay, so when a car turns a sharp turn, so what happens? The passenger get pushed sideways. Okay, so this is the inertia of direction. So the next tendency of sound wave is that uh, the material, the medium must have inertia. Now, inertia to is clear. What is inertia? Now, how it happen inertia in the propagation of sound? So, inertia helps the particle to resist the change in motion and transfer energy between them. So, inertia helps the particle to resist change in motion. So, the example of this inertia could be say like we are having heavier particles जैसे कि for example in solid. So in solid particle the rate of sound wave is the maximum. So sound wave travel faster in solid particle. So because this is the property because the medium is having inertia and this inertia helps the particle to resist their change in motion. And the last property is medium should be frictionless. So these are the 4 properties of the medium. Is it clear, everyone? Is it clear, everyone?
Yes, ma'am.
Okay. Okay, so in next class, we will continue this chapter with next topic. That is, I think next is the properties of sound. Yes. Okay, everyone. Done? Writing part is done, everyone?
Ma'am.
Okay. Okay, then. Bye-bye. See you tomorrow.
Bye, ma'am.